Hey everybody, I'm Andre. I'm a Dutchie, hence the funny accent. I've been in IT since 1989. So my brother has a 14-year-old daughter, and I keep explaining to her that we used to have to call the internet. And I get really confused looks. What do you mean call the internet? Like it wasn't floating in the sky. You just had to call them, and then you could use the interwebs. It doesn't understand. Hey, come on in. 89. I started working with databases around the mid-90s somewhere. I forgot exactly when. And I am a freelancer, but I work for a bank in the Netherlands a lot. They have this thing that as a freelancer you can only be there for 2 years and then you have to go away. So I've been doing that since 2002. Work for 2 years, go away. Work for 2 years, go away. You have to disappear. We've got this figured out now with the manager that works there. It's a half year plus a week, and then I'm back. Hello. In the beginning, they gave me new names in the Active Directory, but now they just reuse the thing because they know I'm going to be back. Fast forward to today, and for the story itself, we moved to Azure, right? The banks are. This is not too long ago. Banks were, hey, we will never ever run our stuff in the cloud because not secure, right? We are an important company and we will not run into the cloud. So this bank crisis happens and the Dutch government has to bail out a bank and actually buy the bank so it becomes owned by the Dutch government. And they sold off half of the bank to, I think it was Santander, a Spanish bank. So suddenly half that bank finds itself without a data center. So what do? They go to the cloud. And they did that really quickly. All the other banks in the Netherlands thought, what if they have a commercial advantage now? Because that went really quick. So fast forward to today, the bank I work for has a super modern dual data center, and you can't run it unless you're legacy data. So if you have systems that cannot run in the cloud for whatever reason, it's just not possible, then you're allowed to run in the data centers of the bank, and everybody else has to go to the cloud. So that's where we are now. I had to move my SQL database as well, because I had an on-prem database. It was an interesting one. It was 150 terabytes, and most of the data was in 3 tables. I have one table that's 60 terabytes, hundreds of billions of rows. Works fine. If anybody ever comes up to you and says SQL Server doesn't scale, send them to me, I'll show you the thing. It's an 8-core VM, so it works fine. Only problem that we get a lot of data every day that we have to ingest, and we just ran into the BCP speed, right? We couldn't ingest it fast enough. And also, creating a non-clustered index on a 60 terabyte table takes, guesses, how long? 4 days. Yes, 4 days. You have to pick a long weekend to do that. So we moved that thing into the cloud. We moved it to Synapse Compute Pools because all you need is a credit card, right? And if it doesn't perform fast enough, you move the slider. Job done. So fast forward even a little bit further, I got pulled into a FinOps project at the bank because guess what? My database, my cute little database, is in the top 10 of the most costing stuff that we have at the bank. Altogether with, interestingly enough, not just the compute pools, but also Data Factory, and because of the loading and all the things that we do, and I have some tips on that as well. We spend about 150,000 euros per month. The number one, 800,000 euros. I'm not worried yet. So there's some interesting cost, especially the 800,000 euros costing number one. That's from the cloud team. That's an internal data collecting system to check if everything is according to the rules. It's not even making money for the bank. At least mine does some actual work. Oh well. So if I go back a bit, because I'm going to talk a bit about how do you save money and how do the people that want you to save money look at this thing and why there's a disconnect between those and how things used to work. So this is what we used to do when we didn't have cloud. You start a project and a project manager has to write something called a project start architecture and has to describe what you're going to do, how big the team will be, and what kind of hardware you need. So before you even start, and it has to be approved and bought and racked and stacked and installed and delivered, and then you can start your project. Stupidest thing ever. So before you even start your project, you have about 30 servers running, right? Web servers, database servers, dev test, prod, acceptance testing, everything is there before you even start. It was silly. I've been in a project, not at a bank, but at a different company in the Netherlands, where it took so long to deliver something that before we could go into production, we had a different project to renew the production hardware because it was out of date before we could start. This was not, it was a government thing. I'm not allowed to say which government thing it was. The funny thing is they let me describe what they do. So here it comes. It's a government agency that if you make money, they want half of it. Can't tell you who they are. Anyway. So a few things first. The term FinOps doesn't really stand for financial operations. We don't talk to the auditors of the company or something. It's more a project that is closer to the techies, and it had more to do with automation. It's closer to the DevOps. It's more how do you train other departments on how to save cost in Azure. Where are their costs? How do we make this into a continuous thing? So it's more like finance and DevOps. That's more where it comes from. There's an organization called FinOps.org, and they have a lot of documentation on how they see this. Of course, you can give it your own explanation, but this is what we're following here. And they have a framework, but it's basically all the same. Everybody has their funny descriptions on how they want to do this. But you start with just making it visible, like where are our costs? Azure is really good at telling you what the costs are. And there are some problems with that, but we'll get to that. And then when you can see how much it is, you have to tell people, right? The bank actually had project managers that thought, okay, we just have to force people to not make expensive VMs and all these things that they can understand really quickly, right? Why are you running this? First thing we found, 20 VMs with 0.5 terabyte of memory and with a usage of 1%. Continuously switched on. So easy job, right? Switch them off. And the mistake they made is ask the business if they could do that. What do you think the answer was? No. But you don't use it on a Sunday, but we might. How about we give you a button, so if you want to use it on a Sunday, you can switch it on. Yeah, but then we need developer time, and there's a new project, we don't have the budget, and anyway. So never ask the business. It's weird. At some point when you've made it visible what your cost is, and there's all these cost optimizing tricks in the Azure portal as well. You can buy third-party software that will tell you, hey, this is 1% utilized. Hey, you have 500 IP addresses from VMs that you've thrown away, but the IP addresses are still there, and they don't cost much, like a euro per month or something, but 500 of them. Real money, right? So there's little things that you can do, but there's many challenges. And we'll dive into some examples that I found later as well. The hardest part of, when you find a VM that's underutilized, it's easy to just go, sorry, but we're just going to switch that thing off or make it a bit smaller. It is so decided by the boss. But for many things, we need to reorganize, refactor some way of how our application works. And that means you need developer time. What do developers do? They're in an agile project. They have business people put in what they need to do, and they poker the features. What they never poker, and the features that you never get is the features that they've already built and that you need to refactor, right? Wait a minute, this is not a new feature. This is not for the business. No, this is just to save money. And banks look really funny when you talk about saving money. Like, save money? What? Until it starts costing real money, right? So there's a whole lot of things that you need to, that you're going to run into. What you promise your project manager that says, hey, we need to save money, and you go, let's do it. And then you never get approval for it. There's automation that you might need, because in cloud land, it's easy to say, yeah, we just need to switch it on, because that's how you use cloud resources, right? They're flexible. So everybody says you should just switch them on when you need them, and up when you need it, and down when you need it. Well, you might need automation for that. At the bank that I work, you know, the small companies do portal, click, new, add, move the dial to the right, that kind of stuff. Bank that I work, not available. We don't have access to the portal. If we haven't automated it through a pipeline in DevOps, it's not happening. We can do this in dev, we can make something and then reverse engineer it or something. But something that we need to happen in production needs to be done through DevOps. How do banks do DevOps? They have teams with developers and the DevOps person, right? There's a cloud center of excellence with magic people that make scripts with all kinds of rules, and they have subscriptions in like a tree. So you get a subscription, but there's a subscription above it that arranges all the networking, so you cannot make a VM that has an IP address open to the world or something. That's not possible. So there's all kinds of security baked in. And then the idea is that the teams themselves make their own whatever they need with automation. But then they just hire somebody in the team that does that. So we have many, many teams, and all these teams have their own DevOps person, and they're all super busy, right? So it's really hard to get that done. There's many more things that we could just talk about this thing the whole time, but I have some examples of weird ways that we saved a lot of money that was really hard to convince people that that was needed. Because the big problem, keeping an eye on the time here, totally fine. The big problem is that managers that do FinOps processes, and all these tools that you buy that show you where the cost is, and all this, there's this levels, right? You can show back, right? These are the costs, dear department, this is what you burn. So just show them for a while, see what happens. Maybe they feel guilty, or maybe they do something, or maybe there's low-hanging fruit. And then there's chargeback that you can do. We're going to take this out of your budget. This is just what you do. There's friendlier ways of, hey, we're not going to charge you for this cloud burning, but if you manage to save something, we'll give you more budget next year for cool stuff. It's a bit of a carrot and a stick kind of thing. But it's all related to, in Azure, there's two things, the control plane and the data plane. The control plane is what you can hit with your DevOps. You can say, create a database or a SQL server with a database. But as soon as you want to create something inside the database, like tables and data, your DevOps doesn't do that. ARM templates and Bicep templates and Terraform and such, they can't touch that. That lives here in the dangerous world that managers don't understand, right? In the data plane. So we have a DW6000C. That's a Synapse compute pool, and it costs about 50,000 euros a month. And the utilization is high. And they look at the software looks at the thing, and the management looks at the thing and go, you've done that well. It's at a 6,000, which is expensive, but the utilization is high, so we're good. the fact that we actually were doing very stupid things with it, which caused the utilization to be high, that's the problem here. And this is the big problem with all these FinOps projects where you look at, you measure this, but your problem is here, right? So you don't see it. It's like these old SQL Server in fragmentation. There's a fast way of looking at the fragmentation and a slow way of looking at the fragmentation. And the fast way looks at the intermediate levels, and the slow way looks at all the leaf levels. I don't know if you've ever seen that. And then you can choose if you want to rebuild or reorg. And the reorg does only the leaf levels, and the rebuild does everything. So we always choose the fast way of looking and the non-invasive way of fixing. So we're measuring intermediate levels and then trying to fix the leaf levels. So you're measuring one thing and then you're fixing the other thing. Oh, by the way, this is not to talk about that, but stop rebuilding your indexes. There's no need for that anymore. Come on. Your storage is lying to you. It throws it everywhere. There's edge cases, so let's don't take this at 100% value. So this is the biggest challenge for me as a data engineer. My management has tools. They know what the bills are. They see the cost, and they go, "You're doing it well, but you're expensive. What do we do now?" This is why I got into the top 10 of the bank cost, and they wanted to exclude me because all the tools said you're not really. It's really hard to save costs on this thing because he has resources rolled out, but the utilization is not that is okay. So all the tools told the manager, there's no way he can save money. Well, that sort of kind of was. So what did we do? By the way, no questions here, but if you have any questions, if nobody asks anything, we're going to be done soon. All good. I don't care. It's fine. So I have an example. If I actually press the space bar. There we go. So my Synapse compute pool is around 200 terabytes. And like I said, there's just a few tables, and they're pretty big. Interesting fun fact about Synapse, if they say it's unlimited, not true. If you use column store compression, it's unlimited, but we're not using column store compression. We have 3,000 users, again, documentation of Synapse says, you can't do that. Send them to me, you can, I'll show you. We have 3,000 users on the thing, but we have non-clustered indexes. We have really specific indexes with specific queries that hit that thing. We tried to combine column store compressed in the tables with non-clustered indexes, and that's the worst scaling scenario that I've ever seen. If you get one row from your query, it is okay. 10 rows, it's, ooh, that's slow, and 100 rows is coffee time. Going from a non-clustered index into a column store doesn't work. It doesn't scale at all. It was really bad. So we had to turn our column store to just a regular clustered index with non-clustered indexes. And the reason that this Synapse just still works really well is because the ingestion speed of the data, the power is really good. So we like that one. And we can have 3,000 users because the queries are all really fast. Also, if you read the documentation, Microsoft says, don't use this for OLTP scenarios. This is sort of kind of an OLTP scenario. There's ETL in the front, but the back is just, it's a fraud and compliance database, so I can't tell you what it does. But I'm not even allowed to look into the database, which is interesting if you're the admin of the thing. But, so, we had one query, for instance, that did a select top 25,000. And it was really slow. Guess what? And this caused the utilization to go up. You can only run like 30 or 50 queries at the same time in a Synapse if you have the thing moved to the right a lot, right? If you have it on a DW1000, you can only run like 15 queries. But if you have a 6,000, 50,000 euros a month, but who cares? You can run a bit more queries. The top 25,000 is killing that. We have to have it on 5,000 instead of 3,000 because of that one query that did a top 25,000. So we, instead of just leaving it on 6,000, we went, okay, let's investigate why this is. Turns out, if you've ever played with the Synapse, you might know that every table that you create becomes 60 tables. Right? It makes 60 tables for you. That's why it has so much power. It distributes all your data. So if you do a top 25,000, what does Synapse do? It does a top 25,000 on all 60 tables, which returns 1.5 million rows to the control node, and then does a top 25,000 on top of that. And that was a bit expensive, especially if you have 160 columns, and the developers have said, we need everything. Right? So we do a select star, which select star is bad. Select star in column store is even worse, but we don't use that, so yay. But that's the problem that we have. So we've also ran into issues where we had to split a table because we hit 60 terabytes, which is the limit for if you're not using column store in a Synapse. And we called Microsoft and asked, hey, I can see the reserved space is 65 terabytes. So does it just keep going? And you've just documented this as a theoretical limit? Or is it really going to break because it's going to stop growing at 65 terabytes? And Microsoft's answer was, no idea. We've never seen this before. So we didn't want to wait for that. We were at 61 terabytes already. And we just split this thing up in a multi-years tables with a view on top. So, and this is where I lost all the project managers, right? I thought you were trying to save money instead of just building new features. No, this is refactoring so we can make the thing cheaper. The whole goal is to make it from the 6,000 to the 3,000 again. So it's cheaper. And it's really hard to convince that this is all needed to save some money. Here's another one. 6000C is not the only one that I have. I've got 1,000 and a 5,000. So the 5,000, and this is not just about Synapse, don't worry. So the 5,000, everything is tuned really well. They use Informatica to load the data, but Informatica understands Synapse, so all good. But in the end, an analysis services shows up and wants the data. And to make analysis services faster so you don't have to refresh the whole thing all the time, they've partitioned it. And then somebody decided, that some partitions might change, not just the latest one, and we don't want to figure out which one changed, so we're just going to refresh the whole thing every day. So what does analysis services do if you do a full refresh, but the thing is partitioned? It sends a query for all the partitions at the same time. What does Synapse not do well? A lot of queries at the same time. The limit is 50, and then it breaks. So the thing was overloaded. So the advice you give is, well, maybe, just maybe, we should dump the data when we're done with the ETL process into Parquet files, and then let Synapse serverless pick up the data for analysis service. So you completely offload it. And I was so proud of myself. I thought, fixed it, tuned it, re-architected it, all done. And I got into a whole political debate on, well, but now we're not using the Synapse anymore, and is it the right technology? And other architects became involved, and just fix the thing. So it's operating on that data plane from a cost perspective, to get developers to go, yeah, but can we not fix this another way, is so hard. It's so hard to convince them. Here's another one. Where am I? Half hour? Okay. What's the end time for this? 20. I have 20 minutes? Okay, good. I keep looking at the schedule on my phone, and there's a session, good. And then later I use my laptop to look at sessions as well, and the session is now, I need to go if I want to see it. But they're using Session Eyes, and Session Eyes shows you the schedule in your time zone. My phone is on this time zone, my laptop is not, so it shows different times. Confuses me. I've showed up too late for a session a couple of times. Fortunately, not my own. All good. Here's one. We were using Databricks. And we needed to do API calls because we have we use a software tool called Intercom that you can use for customer service. And Intercom has an API call for the conversations that you have with the customers. And they also have an API call for conversation details. And what you need to do with Intercom is really silly. You get a block of conversation IDs, and then you have to do an API call per conversation. So for every conversation with every customer that you have to do an API call at night. Sometimes it's in the millions. It runs for hours. And you can't parallelize it. Intercom has made it so that you have to just do it that way. This is a design that I did. It was stupid in hindsight. We did this from a Databricks cluster, because when we were done with getting all this JSON data, we needed to merge it into our Delta tables. So I thought, no, let's just use the same technology, good. The result is that there is a Databricks cluster running all the time that we are talking to Intercom, but we're not using it, right? It's just doing API calls. So it's just the little server in the middle, instead of all the worker nodes, they don't do anything, and the little server in the middle just goes API call, API call, API call for 4 or 5 hours. And then 5 minutes or so, it uses them all to merge the data. So we re-engineered this thing to use a container for the API calls. To start the container starts the Python code, does all the work, and then kicks off the Databricks process, which starts the cluster, does the work, and switches it back off. This is what you need to do with cloud technology, right? Change your mind. If I can give you one tip on what you need to do with your cloud technology, change your mind all the time. Build something, architect something, and then analyze it after a year, maybe every year. Look at your stuff. Are we still doing this the way we think is effective, or do we need to re-engineer this thing? Is there something new in the cloud that we can use now, right? Can we make it more secure, because now suddenly we can use managed identities and we don't have to use passwords anymore. So we can get rid of all these key vaults because they don't have passwords. Can we move things to containers? Because we're using this cluster, but it looks stupid. So changing your mind constantly, refactoring your stuff, something that you have to factor into your process if you move to a cloud environment. I've had discussions with these bank project managers on the technology that I chose, and now I'm working towards a version 2 of this thing. It's Data Factory, and we use Synapse. And I want to take all the ETL out and use Databricks for that, and just use the Synapse for that little OLTP type E part. And they go, but Andre, did you then make a mistake with your initial assessment? No, we went with Synapse because we understood that thing. And that was the first thing that was available in the bank that you were allowed to use, because they have rules. And Databricks was not allowed. It wasn't even around at the time, I think. So now we're refactoring it. And I had a hard time convincing managers that I was refactoring something instead of changing my mind and making a stupid decision and making it right or something. It's something that they have a hard time understanding. There are a lot of them. I keep saying they and them. There are also really nice ones and good ones. A lot are still in the we need to have a SQL server. How big does the hardware need to be? This much, and for the next 6 years, and then you change to a newer version of SQL Server when you buy new hardware, and they're still in that mode. I've had whole discussions on how much storage do we need for something. I'm like, okay, just one storage account. Yeah, but how much storage do we need inside the storage account? Who cares? Well, we need to specify that. No, we don't. Anyone want to guess what the maximum is for a storage account? If you just make one storage account, how much data can you put in there? 6 petabytes. You just make a storage account. Your money will run out way before you've put 6 petabytes in there, right? That you don't need to specify all these things. So it becomes important to keep on reinventing the wheel, basically. And you can't just do that by yourself. You have to convince your managers that you need to do this. So Here's one. Bob Duffy found this out. This bit us as well, big time. We have data factory processes that did the old school way that we did it on-prem. Data comes in, and we start moving it around. Like inbox, processing, processed, archive. Right? You move the file. You keep moving the file around. And we use Data Factory to do that. And Data Factory doesn't move a file. It makes a copy and then deletes the old one. And you have to specify that in your Data Factory. Also, it's very slow if the file gets a lot bigger, and it's really expensive. It's very expensive to do it that way. I had an Amazon S3 bucket with 50 terabytes of data, and I tried to use a normal Microsoft Storage Explorer, like the GUI tool, to copy the data across, and it kept crashing on me and timing out, and it was just not working, and I didn't want to do it in bits and pieces because, come on. And I wrote an ADF pipeline that did it for me, and it went to town and did it in like an hour, and all done. And then the bill came in. Moving 50 terabytes of data just with one ADF pipeline that ran for an hour was 4,000 euros. Yeah. So, Andre, please don't do that again. and these are the things that you learn when you start tinkering with it. You will run into limits, and that use it this way is not expensive. Using it that way, stupid expensive. That used to be the joke about Cosmos DB, right? If you design it wrong, every query that you run will cost you anywhere in between 0.0001 cents and all your money. Depends on how you use it. So people got afraid of that thing until we understand it better and use it specifically for what we need it for. So what happens here? Azure Storage has an API. You can tell the API to move a file. And moving a file in Azure Storage doesn't move the file. It just changes the metadata of the file. This whole directory structure is just metadata. It doesn't sit in... Hold on, there's a disclaimer here. That's if you have a storage account with hierarchical namespaces switched on. The HNS-enabled thing. Other funny thing, if you didn't enable that thing when you created the storage account, you're stuck. You can't change it. You have to create a new storage account and move the data to it. Sounds expensive. But what you could do is do an API call to Azure Storage, so it changes the metadata. And Bob Duffy, this is a long URL to find it, but if you just do Bob Duffy Dublin or Bob Duffy Ireland or something, you'll find his blog. He works for ProData. It's his own company. But he blogged about how you do that from Data Factory. So if you now have a Data Factory that does, file comes in, I'll move it here, I'll move it there, I'll move it there. Stop doing that, because that's expensive. So you can just use Bob's API calls from Data Factory that doesn't move the file, but just changes the metadata, and your speed will go up significantly and your cost will drop significantly on a stupid thing like moving a file in Azure. So, sometimes Azure is really forgiving and cheap, and you get a lot of power, and you think, oh, this is so cool. And sometimes you think, seriously? What's going on here? Why do I have to make such a complicated Data Factory to do this the right way? Why is that not built in? But that's how it works sometimes. So, if you do all these things, then in the end, your scenario looks more like this, right? Your data plane is not that scary anymore. And this is what we understand, right? We understand this thing. And as a data engineer, I don't have that much knowledge about that thing above. I roll out my own instance. I can do bicep and such. But that's the hard one for me. Where are all the costs? The hardest thing is if a manager asks me, so many projects. We're going to make a data factory and a storage account and some integration runtime to get some data and move it into the cloud, process it at night, then throw it into Power BI. And the first question I get is, how much is that going to cost? If I would pretty please describe upfront what the cost would be, and then so they can approve it. I'm like, how there's a calculator, right? And Has everyone ever used the calculator in Azure? Were you right when you were done? Did you look back and go, I was actually not far off? Or
I tell the guys that the time that I spend using the calculation costs usually more than the thing itself.
so for this data warehouse, the FinOps with the 6000C, I did that calculation. And I told them, and it's now documented forever, so they can look back if they want to, and they will see that I predicted that this thing was going to cost the whole project 5,000 euros a month. It's 150,000 a month, right? I was a bit wrong. So I'm having trouble with this upfront thing. Like I'm not sure if I'm comfortable.
Did you find a good excuse now that you tell people if they ask you?
Yeah, they've started using that thing with we only had 1,000 users, and now they have 3,000, and I know managers can calculate as well. So, but I have some excuses here. They have some interesting projects that they're now doing with that thing. So, fortunately, it's popular enough that nobody cares that I was wrong. The thing works; it works fine. They can do whatever it is that they do with that thing. There's interesting stuff. There was I think it was Danske Bank was involved in a Russian mob scandal with money laundering. And every bank in Europe had to calculate what their exposure was to this thing. Did we do business with this bank and how much? Because at some point the accountant that was looking into that was assassinated by the Russian mafia. And we had to build a query that, sometimes I sound like I get a badge and a gun or something from my work, but we had to calculate what our exposure was. So that's literally writing queries blind, because we don't have a test system. I just had to write queries and then give it to the Power BI person. And he goes, yeah, it doesn't work yet, I know, but I probably made a typo. Didn't you run this thing? I can't. I'm not allowed to see the number that comes out. It's so weird. So one thing we're doing now is creating test data. But anyway, I would think that the hardest thing for me was talking to the managers that start a money-saving process. They talk on that level. They have the tools and they have the visibility into the cost. They can tell you exactly what the tool knows. They can show you what other departments do when that use similar technology. Maybe we can help each other. They can enable a whole lot of things, but what they cannot see is the language that I speak. Is this language here, the data plane? Data plane just doesn't mean data. It's also if you make a storage account and you make inside the storage account directories and files, that's also data. They can see there's a lot of data in there and you're moving a lot, but they don't know if that's legit, if that makes sense what you're doing. That's where the re-engineering comes in. And now it becomes my job to explain them how this works, because I can't fix everything. I sometimes have to have help from developers. And I'm the data engineer, I'm not the project manager or something. I cannot put a team of developers on a task or something. I don't have that. That's not my pay grade, right? That's not what I was hired for. So there's a lot of convincing, explaining that I had to do to make this work. So I used the SQL bits thing to make a friendly data plane where the big fire is just now a cozy fire. But you still have the Demogorgons everywhere, but they're smaller. There's one as well, because they also live on that level. But I guess there is a process that you can follow, right? If you go to FinOps.org, it will explain. You can show people first. Then maybe you can, on a higher level, you can restrain people. You can say, hey, you can't make these virtual machines. You cannot use those, right? Only these ones. You can restrict people in what they can do. And they wanted to not restrict people a lot. So we basically went to town. Every project went to town and created hugely expensive resources. So that's one thing that you can do. And enforcing it comes way later. This first showing people what they did. But the hard part that we didn't get right in the beginning is how to translate all this data plane stuff. So now I'm tasked with getting best practices from what I did so we can share it with the other departments. So basically, now other departments that use a database get a visit from this smartass telling them, hey, I did a lot of things wrong. Let me tell you what to do. Like, seriously, who's this dude, right? So this is a hard job. I'm not done yet. I don't know. I need to use politics, and I'm Dutch. I'm not very good at that. We're quite direct in things. We'll see what happens. Any questions before we go for a drink? Or is it not time for a drink yet? Yes, okay. So Friday, I think there's like 2 or 3 more sessions left, and then there's a whole day tomorrow. Don't forget to go to the party tonight. That should be fun. If you have any questions, let me know. Also, there's supposed to be a QR code, and of course I forgot to do that. So if you submit feedback, if there's these numbers like 1 to 5 or something, I'd love a 5 if that's the highest. 10, then I'd love a 10, but that's all fine. If you have something, if you have feedback, please write something. That's way more useful to me than the number. Right? If you have something to say, please write it. You can be friendly about that. Like, you sound like a friendly guy, but all good. We're all friends. No problem there. With that, I'm going to let you go and find another cool session. How about that? Thank you.